So we're gonna start the the first session of this room. We're starting with Matt Schaffer's mapping your world with Ruby. So he's from Gifu in Japan, actually. So he lives and works in Japan. You work for Elastic, yes. Right, right. So this is about his like volunteer um, work
Yep, exactly.
called Safecast.
Yep.
So Matt-san, お願いします。よろしくお願いします。
Thank you. Is the mic okay? Everyone here? Good. And thanks for coming. I know it was short after lunch. Yeah, that's okay. Yeah, I'm sure there will be video or something like that too. Cool. So thank you for coming. Today I'm going to talk about mapping your world with Ruby. Like you just heard, my name is Matt Schaffer. I'm a site reliability engineer. I work mainly for Elastic, also a sponsor here today. And then also my volunteer work is for an organization called Safecast. And that's what I'm going to talk about today. That's where I get to use a lot of my day-to-day Ruby. So I'll start with a question. Are you safe? 安全ですか? It's hard to know for sure, right? It's a complicated question. So this is a picture I took and put on Twitter about an hour ago. So the conference room where we saw Nobu speak was reading 0.1 microsieverts per hour was the ambient radiation level in that room. 35 counts per minute. This is the radiation levels that were recorded as I tried to ride a bus at Hiroshima Station. I didn't have 1000円両替できなかったで、一回タクシー乗って rode a taxi down, and then walked from the hotel back to the conference room. And as you can see, these are all the radiation levels that were recorded as I was walking to the conference today. These are some radiation levels taken as part of a much larger data set around the Hiroshima area. So you can see right there it was reading 0.17. It's all color-coded, so you can get the lower levels are blue. There's a little pink spot here that I might try to check out later, but it's not too high. But these are all the ambient radiation readings around the Hiroshima area here. And this is also from the Safecast website. So if you want to take a look, if you have your laptops or something, you can take a look there. These are PM 2.5 readings around the Boston area. This is air quality. So you often hear on the news people talking about PM 2.5 levels. Is it low? Is it high? This is actually still new information to me. I can't tell you if it's particularly low or particularly high. I know a little bit about radiation data. PM 2.5 and air data is something that I'm still just learning. And this is a Kibana dashboard that we recently set up that shows one sensor here and two sensors here, recording some different PM 2.5 readings around the area. So all the data that you just saw is gathered by a group that I volunteer for called Safecast. And what we're trying to do is answer the question, are you safe? And one of the best ways to answer that question is data, right? You can't know for sure if you're safe if you don't know what these levels are. These are all factors in your environment that you can't see, you can't feel, but they do impact you, they do impact your family, they impact your loved ones. And so first off, I'm going to talk a little bit about the Safecast project. Then I'll talk about how Ruby fits into the Safecast project. This is RubyKaigi, so I wanted to spend some time talking about how we use Ruby at Safecast. And then also some of the learnings. I've been working with Safecast for about 4 years now. I've learned a few things. It's my first large-scale volunteer development work, which has been interesting. I've been working in software for, I guess, 15 years now, but always for pay. So after 4 years or so of doing volunteer software work, there are some learnings there too. And then also involvement. So hopefully, as part of my talk, I can encourage some of you to either get interested in Safecast or a similar project, and maybe do some volunteer software development. And I'll tell you a little bit about why I do that and how you might be able to get involved if you're interested. So Safecast started March 11th, 2011, the Tohoku Earthquake. that I'm sure affected many people in this room. At the time, I was living in San Jose. My wife, who is from Gifu, she has family, of course, in Japan. So one of the first questions we started asking is everyone okay? You know, all of our family was asking, is everyone safe? Is everyone okay? The people who started Safecast were actually much more immediately affected. Peter Franken, who was one of the main people that started the project, his wife is from just north of where the earthquake struck, and he was in Tokyo. So the earthquake was basically right between him and his wife's hometown. So when the news of the earthquake struck, the first thing he wanted to do was help. What can I do? And then the nuclear disaster followed after that, and that effectively separated him and his wife from their hometown. So the first thing I started digging is, well, what can they do? This affected them. It left them wondering, and it left even me and my family wondering back in the US before I got connected with Safecast. So shortly after the Tohoku earthquake and the Fukushima nuclear disaster, a lot of people, as I said, were left wondering, how are the levels? Is the radiation level okay? Are people safe? And this is an image that was taken from NHK News on April 22nd, so even a month or so after the quake and the nuclear disaster. And it's got, I won't comment on the levels too much, but if you know Japanese geography, you'll notice there's a prefecture not on this map, right? There's a city not on this map. It's Fukushima, right? The actual accident was north of what is on this map, right? So they have no data for the area immediately affected by the incident. So, like I said, it was a big problem. There was no data. No one really knew. And so what happened in the early days of the Safecast organization is Peter Franken and Sean Bonner and Joey Ito got together on a Skype call and started saying, well, what can we do to get that data? How can we find out if our family is safe? How can we find out, should we leave Japan? Should we, try to get our family out? Are we okay to stay where we are? Should we panic? You don't know what to do. So the first thing they did was get on a call and try to figure out, can we get the data? Is there data somewhere that we can simply just get up on a website and share with people? And they quickly found out that, as you saw on that NHK image from a month later, there really wasn't any data. There were a few organizations monitoring radiation data, but the information was very sparse. It was in a variety of formats. It wasn't easy to get up on a website. And so they quickly abandoned that idea of just trying to gather other people's data and get it up online for people to see and use to make decisions. So they thought, well, what if you could crowdsource this safety data? What if you could get the community to go and measure where they want to measure? So they started working on that idea. Could they give people Geiger counters to start walking around and measuring the things that they wanted? And they quickly hit the next problem, which was there were no sensors, there were no Geiger counters. Right after the accident, the world stock of Geiger counters exhausted within about 24 hours. So it was very, very difficult to get a Geiger counter shortly after the accident. Very expensive. Like even today, long after the accident, off-the-shelf Geiger counters can be $700, $800. And then, of course, right after the accident, everyone is trying to buy them, so they were extremely expensive. So the plan of crowdsourcing didn't really hold up. They would have to get 100 or 200 sensors. And at this point, it's like, oh my God, right? What do you do? So here we have a major nuclear accident, followed up right after an earthquake. We don't know if our families are safe. You have to remember, and I didn't get involved with Safecast until a couple years later, but in the early days of the Safecast project, the clock was ticking, right? Like the people who were on this initial Skype call, they had family and friends very close to the incident that they had no idea if they were safe or should evacuate, and they had to just go with what was on the news, which wasn't very much. And so, like I said, they got on a Skype call, and they started to broaden the scope. They started to throw more people on it, try to figure out, well, what can we do? We don't have a lot of sensors. Sensors are hard to come by. The people who might be recording this data aren't recording a lot of data. They're only recording it in small spaces or just maybe 1 or 2 measurements per prefecture. And they got on a call. They talked it out. Obviously a lot of experienced people on this chart here, and they came up with duct tape. Now, duct tape is great. You can do a lot of things with duct tape. So what did they do with the duct tape? What they did is they didn't have 0 Geiger counters. They actually had 2. I think they had 3 in the early days. They managed to get their hands on a couple. but not enough to crowdsource the data, not enough to put them all over Japan. But what they could do is duct tape it to a car window and have that car drive around to try to pick up the measurements. And so they duct taped it to the car window of this truck driver, who was one of the early truck drivers doing relief support to the Fukushima area. And they said, okay, we're going to tape this Geiger counter to your car window. Please, as you're driving supplies up on this route, take a picture of the Geiger counter with your iPhone while you go. So you take a picture, it gets the GPS coordinates, and you have in the picture, this is one of the example pictures, you have the reading. And it worked, right? It was the initial map, it wasn't much, but you could click on each one of these points and get a radiation measurement for each point along the route. And so you could see where the problems were. You could see where the higher levels were. You could see where the lower levels were. And that gave the Safecast project some momentum to say, yes, there is something to measure. We can drive the 1.2 million kilometers of road in Japan, gather these measurements. But of course, taking pictures of a Geiger counter is maybe not a great way to do it. So by that point, it was it was about a month later by the time they developed this one. They had a lot of people on that initial Skype call. They started working on a solution to automate this problem. So instead of a camera, they took a laptop, and they hooked a laptop to a sensor in a weatherproof box, so that what the truck driver was doing with his camera, they could now do every 5 seconds, right off of the Geiger counter into the laptop. You have a GPS going into the laptop as well, and gather data on that. And with that, they strapped a pair of sensors to the outside of a car, and they drove up to the Fukushima accident. Some of the original heroes of the Safecast project, they had no idea what they were going to get into. People didn't know where the levels were high or low, but they had enough passion and enough family connection to decide to go do this, to go measure the Fukushima area. And some of the initial volunteers have been up to the Fukushima reactor area on a number of occasions to measure data up there. So I think it looks like that's probably Peter driving. But as I said, Japan has a lot of roads. So just one car and 2 sensors, it would take a very, very long time to try to measure radiation data around Japan. So they thought, well, let's go back to that crowdsourcing idea. Let's take all of those components that are in the laptop that we need and the sensor on the outside of the car and get them into one weatherproof box. And then they took that kit and they gave away some of the initial ones for free and had people strap them to their cars and drive around Japan, thereby getting back to this crowdsourcing plan. And I have one of those today. That's what led to the RubyKaigi. And I wanted to pass this around. So folks can take a look. It's not a clock. It's not a bomb. It's a Geiger counter. And you can pass it around. I made that one. That one's fine. You can pass it back. And you can see on the front, it will give you a radiation measurement. On the back is the sensor. So, yeah, you can open it up. That's fine. Yeah, it's fine. So it's in a weatherproof box. It takes radiation measurements from the environment. It correlates them with a GPS value. And so the end result is you can take it, put it on the outside of your car, drive around, and collect data about your environment. Now, this is just one type of sensor, of course. This is just collecting radiation data. But as I said, are you safe? There's a lot of factors. So the Safecast project is growing. This is how it started. So this is the RubyKaigi Nano. It's a mobile crowdsourced sensor. As I said, they gave away these. They built a few of these initially and gave them away for free. But what they found is that it actually worked a little bit better to have people buy and build their own. And so this is Miles Dyson, who recently he built number 2964. As you can see, it doesn't require a lot of specialized equipment. It's a coffee table, a soldering iron, and some TV to keep you company. The build does take a little bit of time. And they found an interesting effect from this, too. Rather than using a lot of off-the-shelf equipment, or maybe giving away the Geiger counters for free, by turning it into a kit, they kept the production cost very low. They only have to charge for the materials, basically. And then the people who take the time to buy and build one of these things then become kind of attached to the device, right? So like the one that I passed around here, I built it. I took time to make it. It took, I'd say, probably about 8 hours or something like that. Not too complicated, but it was a little tricky. So that's my Safecast, my RubyKaigi Nano. And the people who were interested enough to go through this process then were also very passionate about bringing their data to the project. So it was a great way to get in some of these early volunteers to build out the data set and cover a lot of ground. So like I said, it takes some work to solder. But one of the first things Safecast did after introducing the RubyKaigi kit was start to do workshops. And so they do outreach into the community. This is one of the early workshops in Fukushima Prefecture, where they would teach people, maybe with no prior knowledge about soldering or electronics, how to build these devices. And we're up to 76 million data points as of yesterday. And we're up to about 76 million data points as of yesterday and growing. As you can see, the data set is kind of shooting up, which I'm a site reliability engineer. Like I said, makes me a little bit nervous to see this graph, but I'm doing what I can to try to handle all the data that's now coming into the system. We have about, I think it's over 1,000. I don't think it's 2,000 of these devices in the field just yet. But we've been making and selling kits for 6 years now. So there are a lot of these RubyKaigi devices out in the field. And they're being used to collect data that makes up the larger Safecast map. And as you can see, it's not, we've branched far beyond Japan. When I first came into Safecast, I was living in San Jose at the time. And so I got to do a lot of the San Jose measurements and things like that. Of course, we have people who, it's always very popular to go visit sites of previous nuclear disasters. So like Chernobyl, we have people who, you see a little cluster of measurements right around there of people keeping an eye on the Chernobyl disaster. So I know that's this one up here. And then measuring the US, measuring, if you go to like the Safecast blog, you can see there was a recent, I'm blanking on the region, but it was a region in France where there was like a nuclear disposal facility. And so checking measurements around there. You can take your RubyKaigi, strap it to the outside of your car and drive pretty much anywhere. And yeah, so we're using it to build 76 million data points and cover the globe, essentially. Some people even taking it out on boats, getting on-sea measurements, that sort of thing. It's up to you, right? You build the device yourself. You can use it in any way you want. It's weatherproof. Take it outside. We also are having a lot of expert-level dialogue. So this is Asby Brown, another one of our volunteers, who he out here is featured at the International Atomic Energy Agency, giving a presentation on this same device that you now hold in your hands. It's doing a lot to push the needle in terms of awareness of environmental data, radiation data. There's a partnership with the Fukushima City Postal Service to get these mounted on the back of postal delivery bikes. And it was an interesting project to try to find a good way to mount these on the bikes so they wouldn't rattle around too much and they were still accessible. And all this feeds into an open public API, api.safecast.org, which is where people go to upload the devices. So the RubyKaigi has on it, like I said, it's the radiation sensor, the GPS, and then it writes to a micro SD card that's at the bottom of the unit. And then you can take the data from that SD card, upload it to the Safecast API. And then also we have people developing iOS applications and Android applications that connect wirelessly with your RubyKaigi as well. So you don't necessarily, the early stages were all SD based. And then little by little, as more people came into the project, we got mobile developers, we got people who knew how to do low power Bluetooth and things like that to build it out. So this is great. We can drive around, people can measure the communities, they can get a sense of if they're safe. Do they need to evacuate? Can they stay where they are? Is the land safe? I was using it recently. I was looking for a place to build my house in Japan. And so, of course, I brought around my RubyKaigi and checked all the areas. And it was also nice because the GPS, I can see where each land was. So as I'm looking for different places to build a house, I can see, okay, this one was in this area, this one was this area. I get a recording of where I was. But the problem is, so for some places, like the Hiroshima measurement that I showed very early, some of those data points are quite old. Some of those data points are, someone did a drive-through in 2015 and measured the radiation levels in 2015. They may have changed in the past 2 years. They might not have, they may have. So it's important to also measure ongoing radiation levels at fixed points. And so from that, the PointCast program was born. This is a little different than the RubyKaigi. People don't build their own PointCasts. They could, but usually Safecast will build these and then work with someone to install it on a building. So they'll attach it to a building. It reports over cellular data, over cellular networks continuously. So we have a number of these PointCast sensors all over Japan, starting to get them, outside Japan as well. There's a picture of the assembly line. The Safecast volunteers actually put together most of these PointCast devices on their own. They're quite a bit more expensive than the RubyKaigi that's getting passed around. That's part of it too. The RubyKaigi, you can buy for $500, so it's a good kind of hobbyist tool. The PointCasts, since they talk over 4G, they're a little bit more expensive. But thanks to the help of grants and donors, we put these together in the Safecast office and we ship them around to various locations. So here we can see the Odaka Workers Base is one of our recent installations, and they get attached. There's a fixed sensor attached to a wall, and then the device readout, which will either get attached inside or outside, and then that will read the radiation level for that point in time for a very long period of time. So we can do measurements every 5 seconds continuously. The only, it has to be powered. We have to usually work with the people to install it at the location, but most people are pretty happy to have it. And we can see some of our original volunteers too. Here's Peter, who was driving the car. Nick, who does a lot of the mapping work, so all the maps that you saw, that's all Nick's handiwork, and he drives out to install these things too. I look forward to doing more of that work myself. I have 3 small children at home, so when they get a little bit bigger, I think I can probably drive around Japan a little bit more and install these things too. And here's an example of the reading. So as you can see, this is a much longer time span. We have a full month of data from one place. Radiation data does jump around a lot too. So that's another reason why it's useful to get these kind of ongoing measurements. So, you'll see in my walk from the train station or the taxi drive to my hotel, and then my walk to the conference center, there's some readings that are very low and some readings that are very high. Especially if you're watching every 5 seconds or every 1 minute, sometimes you get a quick burst of a lot of radioactive particles, usually coming from just the environment or cosmic radiation. But with this, we can collect a lot of them and start to average them out to get a rough idea and say that this particular PointCast device is reading roughly 32 counts per minute on a moving average. So we can get a sense for what the radiation level is on average for that area, which is for radiation. I know a lot more about radiation than PM 2.5, but one of the important things is the ongoing level. Like if you're in the area, like a quick burst here or there is not going to be a big problem, but the ongoing day-to-day level of counts per minute is what's going to be the most impactful to your health. So that's the PointCast program. This was good, but like I said, we have to work with someone to install it, right? It needs power. We need to usually bolt it to a building. Sometimes we need to drill holes in walls to run from the sensor to the control panel. So we thought, wouldn't it be nice if we had just one self-contained unit? And then so that started our next revision. So we started with duct tape. Now we're on, then we moved to the RubyKaigi, which people could strap to their cars, the PointCast, which people could bolt to their houses, and now we have what we call the SolarCast, which the driving principle is drop and forget. So it measures not only radiation, but as I said, I showed the PM 2.5, right, the air quality. That's something we're getting into a lot more now, because it's another thing that you can't really see or feel, but it can really impact your health. And especially being in the Asian region, being so close to China, there's a lot of interest in Japan in trying to measure the PM 2.5 levels as well. So it measures both particulate, so air quality, and radiation. It uses global wireless, and it's solar power, and it's weatherproof. So the whole idea is this is like a PointCast, but there's no installation required. You just bring the device to the location, you put it on a tripod, you set it anywhere that's convenient. It will do everything that needs to get done to measure that space. You don't have to even think about it. You just turn it on. And they look pretty nice too. So here you can see an example of a box situated out on a rooftop, and I'll talk about what's inside the box. But you can see solar panel on top, all self-contained, all weatherproof, air sensor, and then it has radiation sensors. I think it's on the other side here, and tripod mount, so you can just drop it right in. Yeah, this is the internal. And one of the interesting things is the the Solarcast will use both cellular and LoRa. So it works even in places where like 3G might not be that strong. It'll try to use the LoRa network to get packets out as it can. It's got a lot of intelligence also around whether or not it's moving. So I don't know if anyone does work with air quality, but one of the tricks with sensing air quality is the rate of air intake makes a big difference. So one of the things, and we found this out in the early stages of getting into air quality, is you can't move the unit around. But one thing we did with the Solarcast is it knows if it's moving, right? It's got an accelerometer, it's got a GPS. And so anytime you're taking air measurements, you can know that, okay, this is a high measurement, but we were also moving at a rate of this many kilometers per hour. We know to disregard any air measurements if the intake rate was too high. So we have lots of them. We have many devices. We have the RubyKaigi Nano, which is hopefully still getting passed around. We have the PointCast, we have the Solarcast, and then finally we have, it's gotten to be a very large community. There's a lot of people who help out bringing in the measurements, and they bring their own devices. So we don't limit Solarcast, we don't limit the Safecast software to only take from Safecast devices. This is an open project. Everything is Creative Commons 0 on the data, so public domain data, open source projects for the servers and all the software components. And if people want to publish their own points, that's fine, and there's many people that do this. They use their own off-the-shelf Geiger counters or whatever else they decide to publish in. So that is the basics of the Safecast project. And next up, since this is RubyKaigi, it's a programmer conference, I wanted to talk about the infrastructure and how Ruby factors into this. So api.safecast.org, this is our main product, our main server-side piece. The RubyKaigi, which is that device which has an SD card, users can take that and upload their data points to the API. There's also the PointCast, which publishes through a caching gateway. The PointCast was, of course, one of our very early fixed sensors. So we use a separate gateway to keep IP addresses from shifting around on us, that sort of thing. The software is not self-updatable, so we want to try to keep everything as static as we can. That publishes into a storage layer. We have a real-time website, so that's realtime.safecast.org, which reads off of the API. And then finally, we use the storage layer to generate the tile maps that you saw today. And this is a place where if you saw the title of my talk, you might think, oh, it's a lot of like Ruby code that generates map tiles. And well, this is gotcha. No, Ruby actually has served us much better at the core of this infrastructure than the outside of the infrastructure, which has been interesting to learn. So when you're dealing with things like tile maps and doing web browser renderings of data and interactive maps, JavaScript is a much better tool for that, and that's fine. We let JavaScript handle that part. We have a storage layer that's Postgres. We have the API, which, like I said, so Ruby lives right at the heart of this system. So the API layer is a very long-running Ruby on Rails application. It's the longest one I've had to maintain at this point. And then, of course, the devices run mostly C or C++. The RubyKaigi is actually an Android device, so it's a lot of Android C. And then the gateway is actually a very small PHP service that it does almost nothing. So PHP is not a bad fit for that. All it really does is maintain stable IP addresses, cache stuff to disk, and then once it shoves it up to the API. So it's almost just like a log, like a log forwarder system, that kind of thing. So real-time is WordPress, which is interesting enough. It has a metadata database, which is MySQL, which goes nicely with WordPress. And this is another thing that WordPress, the more I think on it, like I would love to Ruby all the things, but when it comes to a very flexible CMS, WordPress is pretty good at that. And so when we want to maintain content about different devices, WordPress is not a bad system to do that. So we have a little WordPress in there too. We have our new system, which is ingest.safecast.org, and this was specifically designed for the Solarcast. The reasoning here was the API system was really geared around radiation data. So a lot of the data models, a lot of the APIs were really hinged around this idea of you get one radiation measurement from a device. But when the Solarcast came online, now it has many sensors, right? It has air quality sensors, it has CO2 levels, it has temperature, humidity, radiation. It has 2 radiation sensors, actually. And so we started developing ingest.safecast.org, which the Solarcast sensors you saw earlier, that publishes into TT-Serve. This is similar to that gateway system that I showed you before. The Solarcast communicates in a couple of different ways. So the TT-Serve normalizes all that, gets it up to ingest, gets it into the data storage layer, and once again, you have Ruby right at the core. So, and it works well. It goes into Postgres. I started a new project recently to get it into more than just Postgres, but also a couple of different data stores. So Parquet, Elasticsearch, since they're my employer, I thought it'd be nice to try to get that in there as well. So why is Ruby right at the core of Safecast? A couple of pros. Good database hygiene, I think, is a big part of it. People like to knock Active Record, but I think it set a good tone for clean database operations. And so when we developed API, when we developed ingest, using Active Record and using Active Record migrations was a perfect fit to make sure that our database was clean. Good interconnectivity, so we can plug it into a lot of different systems. As I said, it's not just Safecast devices, it's all kinds of devices that people want to plug into this. Ruby does a good job at handling those. And it's approachable, so people can get started very quickly. As far as a couple of cons, performance, sometimes, I won't hit on this too much. I mean, as we all know, Ruby's not the fastest thing in the world. We have hit a couple of problems here and there, but it's mostly okay. Rate of change has been a challenge. Ato has done some work for us in making sure that we stay up to date on versions, but the Ruby ecosystem moves very quickly. And so trying to do that with volunteers is challenging. And the high market rate. So we've had a couple of cases where Ruby is a very desirable skill. And so we've had a volunteer who had tons of free time because they weren't working, and then they get hired in a high-paying Ruby position, and now they don't have so much time to work on Safecast anymore. So people being paid, although it's a good thing, maybe not so much for volunteer. The upgrades, as I mentioned, we've had 6 years of them. We started on Rails 3.1.1. We're now trying to get ready for 5. We're on Rails 4 now. 4.1, I think. This is maybe obvious to people who have been working on software applications, but love your test suite is an important factor here. We have a good test suite on the API product and a developing test suite on ingest. Mind your continuous integration. Don't let it get into a red state, because that's what's going to tell you that everything is still good. And deploy frequently. So we try not to let things hang out too long. We try to push as often as we can to keep things moving. 6 years of the data. We have that too. I wanted to highlight, if anyone's involved in geographical data, geodata, they might know this already, but this was a surprise to me coming into Safecast, is PostGIS is a common currency for this kind of work, which is why PostGIS is still where we do a lot of our mapping and queries and things like that. Growing rapidly, mostly 2 tables right now. We'd like to expand that to do more hot, warm, cold, database sharding, and then I'd like to get into bigger data, so maybe Parquet, get some open, large data. I'm trying to make sure that Safecast works for the next 20 years, and people can now have this really long-term data to do queries over. Next up is the people. I wanted to talk a little bit about 6 years, 30 API committers. We have it's a very spiky sort of contribution graph that we have, being a volunteer project. The key learnings for me from that, I serve as a little bit of an engineering project manager for Safecast. And people come and go. People, sometimes they're available to help out, sometimes they're not, and that's okay. And this is one of the places Ruby really shines, is because it's a very approachable system, so people can come in and out, people can understand each other's changes pretty readily. Good is better than perfect. This goes into don't spend a lot of time working on something for a long time that might never ship. Just try to make little changes here and there. Try to keep moving things forward. Work small, deliver quickly, goes hand in hand with that. And let people follow their interests or their passion. This has been a big one that I try to encourage with the Safecast engineering group, is if you're interested in something, work on it, right? This goes back to the RubyKaigi sensors, which is if you're interested in an area, you measure it. If you're interested in a particular software topic, you work on it. We don't try to steer people too much in one direction or the other. We have things we'd like to fix, but being volunteer, it's much more important for people to work on the things that they're passionate about. And then finally, jump on holiday opportunities. As you might have noticed in your work, and we have that spiky graph, August and then November, December, things usually get a little quiet around the office. And that's a good time to have people kind of jump in to volunteer work like this. So watch for those holiday opportunities when people might not have a lot going on. Maybe people already did their family trip, and now they're just kind of hanging out. So it's a good chance to get a couple of days in, maybe a couple of fixes. And I do that myself. I have 3 small kids. I don't have a lot of time, but the holidays are a great time to do these kind of volunteer opportunities. So I wanted to talk just really quickly about why Safecast for me. How did I get involved with it? I wasn't there at the beginning. For me, it came down to, in 2013, I decided to move my family back to Japan. And one of the first questions that came to us was, is it safe? Right? It's the first question that I asked in the beginning of the presentation. Is it safe? Of course, my parents were, are the grandkids going to be okay? And so I started looking around. There was a lot of fear, a lot of misinformation, a lot of fake news. But I found Safecast, which provided hard data. One of the interesting things about Safecast for me was it's not pro-nuclear or anti-nuclear. It's a pro-data organization. So they don't make any sort of claims as to what's high and what's low necessarily. We can tell you what the max and the min were, but it's up to you to decide whether or not you feel comfortable with those numbers. And so when I was moving to Japan, it was the perfect resource for me to say, yes, my family will be okay. Yes, mom and dad, the grandkids will be okay. It's not a big deal to bring the family back to Japan where I felt like we belonged. Freedom and flexibility is great. Like I said, follow your passion, follow your interest. There's no one telling me that I have to work on this thing or that thing for Safecast. It's up to me. So when I wanted to get Elasticsearch in there, I just put Elasticsearch in there. It's really up to you. It's an open source project, right? And amazing connections. This has been a big one for me, and a little bit of a surprise sometimes. I wanted to highlight a couple folks here. Peter Franken, who really was one of the people who started Safecast. He was at Citibank, Shinsei Ginko, now at Monex. Ray Ozzie was CTO of Microsoft for 5 years. The first time I met Ray, he was sitting across a table holding this crazy snowboard-looking thing, and I was like, "Who is this weird guy?" And I after someone's like, "Dude, that's Ray Ozzie, like CTO of Microsoft." And so sure enough, he and I are sitting across from a conference table, working on this sort of thing. Joey Ito was also one of the original founders. He got to present Safecast as part of an interview to President Obama. And so here, I'm pretty closely connected to that conversation as well. And then finally, Joe Moros, who's not as notable as a name if you Google him, but he's a longtime resident of Japan, originally moved here to work for the electronics industry in the 80s. And so in moving to Japan, he's been an amazing resource for me to learn about Japan and building my house and things like that, because he's so used to the ecosystem. So, and they're just a couple of people. Of course, there's all the engineers that we work with. It's a very big body of people. But making these connections has been fantastic. And it would be difficult to get just working for one organization, right? If you work for one company, you get to meet your VP and you get to meet your CEO and your president, but you probably don't get a chance to meet 3 different C-level people all sitting around a conference table working on this kind of stuff. It goes back to the passion, right? So when we all get around a conference table, it's not like, oh my gosh, I'm just this little engineer and here's Ray Ozzie. It's no, we're both 2 engineers working on a common program that we're both passionate about. So we're trade graphs back and forth and heckle each other's code from time to time. And that's okay too. So that's been a really fantastic experience for me. So in summary, it's Ruby for a cause, right? So a lot of us do Ruby for work or we do Ruby for hobby. We come up with all sorts of crazy little Ruby ideas to work on. But this has an impact on my world and my children's world, which has been amazing for me. Anyone can do it. The people who started Safecast were not experts in radiation. In fact, they knew nothing about radiation. The only thing they had was a common interest in helping to make sure their family was safe. So you don't have to be an expert. Many of the people who develop the Ruby on Rails inside of the Safecast organization never did it before, and that's okay too. Exciting, you get to meet lots of people. Rewarding, I get to help ensure that my area of the world stays safe for my kids and hopefully my grandkids. And it's fun. I like to hack. I think everyone here probably likes to hack too, and this is a fun thing to hack on. And it's always open, so it's an open source project. GitHub.com/Safecast is all of our repositories. We have many. The Safecast API is the main one. Ingest is the new system that we've been working on. TTServe is the Golang piece. I know Golang is kind of the hot thing these days, so if you want to get into that, you can take a look at Ray. Ray wrote most of that code, so don't blame me. The tile map lives here. The hardware devices, the RubyKaigi and the SolarCast live here. And that's it. That's my talk. Like I said, my name is Matt Schaffer. Here's my email, GitHub, and Twitter. 日本語でも一応なんか話せるんですけど、なんかちょっと上級なコンファレンス、なんかRuby会議みたいに多分プレゼンテーションできなさそうと思って一応飲み会とか後で質問とか興味あったら日本語でも OK です。ありがとうございます。はい、以上です。
Thank you. That's a great talk indeed. So, we have 1-2 minutes per question. Does anyone have any question?
Can I ask in Japanese?
頑張ります。
センサーの信号とかって暗号化されてたりするんですか？さっきのを見ると値を偽装するのが結構簡単そうに見えるんですが、アーキテクチャだけ見てると値の正確性を保証する仕組みっていうのも入ってるんですか？
ちょっと難しかったですね。So you're asking about the direction. Is that? Do I have that right?
Sorry, anyone can
角度?
translate? No.
Oh, no, sorry, I missed it. Can we get a translator?
Is that signal encrypted?
No, it's all public. Yeah, SSL, but yeah, the signal comes from the devices just plain initially.
So any bad guys can modify bad data? Is the
Okay, for like on なんか RubyKaigi の上で一応なんか SSL とかないけどアップロードするときに SSL も使ってますし、なんかソーラーカーストも一応 SSL 使ってるけど、I think 多分。
So
But yeah,
how can that
we
be
try to keep the
secured?
system secure. Yeah.
So the question was about security.
Yeah.
How can that be secured? So, for example, anyone can like inject and.
Okay. So not just the transmission, but also the quality of the data. Is that okay? Thanks. Sorry, my Japanese is not that good apparently.
Thank you.
But yeah, we're still working on a good way to prove the data. What we're thinking now is actually kind of a trust situation, similar to what you might see with like a blockchain or cryptocurrency, so that people can sign data, so that they can say this data for this device, I've looked at it, I know that it's credible, and then people consuming the data can trust certain keys. But that system's not implemented today yet. So yeah.
Thank you.
Yep.
終わりかな? 終わりかな? Okay.
Oh.
So, thank you, Matt. It's time. It's time. Sorry. Thank you, Matt. And you feel free to ask any question to Matt afterwards. You're attending the like party this evening yet, right? Okay. はい。ありがとうございます。